We will now solve the first problem on the exam 2017 in the spring. So the first problem is a bunch of different questions simply put in the same problem. So first of all, we have an equation set here. We have an inequality, we have some log in an equation, and then we have two where we need to find the first derivative and a couple where we need to find the integral. And notice as all of these are independent, so you can solve the E without solving the prior ones. So do those that you know how to do. Okay, let's take the first one. This is a typical question which is given almost on every exam, where we have an equation set. So the typical way of doing this is to simply write both of them and use a few seconds to see how you can express either the x or the y as a function of the other. In this case, it's very easy to find an expression for y. And you can insert the expression for y in the first equation. If you write something like this, I will see what you're thinking, and then it's easy to follow your thoughts. By the way, when you do equations, make sure that the equality sign is used correctly. What's on the left hand side must equal what's on the right hand side. Okay, and this follows what we had before. Here we simply take minus 6 times 2 and then minus 6 times minus 4x. And since we have minus and minus, we get a plus here. Okay, then we keep everything with x in it on one side and move everything else to the other side. We now have 27 x's equal to 9. Which basically gives us x equal to 9/27, or 1/3. Insert x equal to 1/3 into expression for y. So what we did basically here is that first we had made an expression for y as a function of x, then we found the x, and now we go back to finding the y. So y equals 2 minus 4 times 1/3, which would be 2 minus 4 over 3. 2 is also 6/3. We need to multiply by 3, both over and under, so we get 2/3. So now we have an answer. The last thing we need to check, or need to do, is to check your answer. Check. So 3x minus 6y, that was the first equation. So we get 3 times 1/3 minus 6 times 2/3, which is 1 minus 4, which is minus 3. And that's what we had in the first one. So this is okay. And in the second one, which we also need to check. We had 4x plus y, so we get 4 times 1/3 plus 2/3. So we get 2, and that's also what we had in that equation. So now, the good thing about checking or testing the results, as we're asked to do, is to see whether or not we're correct. So when we insert x and y and we get the correct answers on the right hand side, we're okay. Okay, B. B is an inequality equation. And here we need to be a little bit careful, because if we insert, for example, let's insert x equals to -1. Then 3x plus 6 gets -3 plus 6, which is 3. That's a positive thing. So when we put the absolute value around it, we still get 3. But let's say we have -3. So you had 3 times x plus 6. If x equals -3, we get -9 plus 6, which is -3. And since we have the absolute value around it, we remove the minus sign and get the plus sign. So when we have this thing here, this equation, we need to make sure that 3x plus 6 is larger or equal to 9, or 3x plus 6 is less or equal to 9. Because if we get -12 out of it, we will remove the absolute sign, and then we also need to remove the minus, which makes it greater than 9. So if this thing here becomes -12, we get 12, which is larger or equal to 9. So we either need to make it larger than 9 or have an absolute value larger than 9. So we need to be less than -9. Sorry, I forgot to write that. Okay. So 3x larger or equal to 9 minus 6. If we move 6 over to the other side, here we have 3x larger than 3, or 3x less than -15. So here we have x, we divide by 3 on both sides, we get 1, or x less than, we divide by 3 on both sides, we get -5. So we have 2 intervals. Just to make sure that you understand what I'm saying here. Let's say we have x equals to 2, which is larger than 1, so it's okay. It should be 3 times 2 plus 6. This would be 12. And that equals 12, which is larger than 9. Let's take something that is less than -5, for example, -6. So it's less than -5. Then we get 3 times -6 plus 6, which is, this would become -18. So we have -12. Which is 12, which is also larger than 9. If we take something in between, let's say we take x equal to 0. This is not larger than 1 and not less than -5, so it should not work. 3 times 0 plus 6, which is 6, remove the absolute sign, and this is less than 9. So you don't need this on your exam, but just to make sure that you understand the thing about the absolute value. Okay, next sub-assignment. Here we have a logarithm thing. And in the formula sheet we have a lot of rules that we can apply here. One of them is that we can, since we have a multiplication sign here, we can put a plus between them. I think it's written something like this in the rules. Also, if we have a logarithm to a to the x, we can put the x in front. And that's what we're doing in the next line here. So we put x logarithm to 2 plus x logarithm to 5. And this is good, because now we have the x's that we can put in front of a parenthesis. Like this. Right, so if we go the other way around, we have x times logarithm to 2, get this term, and then we have x times logarithm to 5, which is this term. So what we can do now is to divide by that parenthesis. Something like this. By the way, we could also put them together again, because this will be this equation here the other way around. So we would have 2 times 5, which is 3 log 10. Okay, what kind of logarithm is this? This is the logarithm of 10. So when we're taking the logarithm of 10, we're basically asking what are we supposed to have here in order to get 10. And that is 1. So 3 divided by 1, and we get 3. So for example, if we want logarithm to 2, that would be the number we have here in order to get 2. So now we get x equal to 3. And what we need to do then is to test your result. So if we have log 2 to the third times 5 to the third, and we simply put it into our calculator, we should get 3, and that should be okay. Okay, find the first derivative. The reason why this is written twice is to make sure you don't misunderstand this 2. Because the 2 here simply means that you take the whole sinus thing squared. So there are several ways to do this. You could put it like this and use the product rule. Because what you need to do then is to take the first term and find the derivative of that. So let's make a small side note here. The derivative of sine is cosine. And the 2x is kind of stuck inside the cosine. And then we need to multiply by 2 afterwards, because that would be using the chain rule. Okay, so we take the derivative of sinus 2x, the first term here, which is 2 cosine 2x, and multiply by the second, plus the first one times the derivative of the second, which is 2 cosine 2x, since they are equal. So we now have two totally identical terms. We have a 2 in front of both, so we will get 4 cosine 2x times sinus 2x. So that would be one way of doing it. Alternative is the chain rule. So this time we're keeping the parentheses like that. And remember that if you have the derivative of x squared, you get 2x. So here we use this as the chain rule on this. We kind of make a u equal to sinus 2x. And at the u dx would then, as above, be 2 cosine 2x. So here we simply get 2 sinus 2x, since we're using the chain rule. And then we multiply by the derivative of our what's inside the parentheses here. So again, we have a 2 times a 2, so we get 4. And we have sinus 2x times cosine 2x, which is totally identical to what we had above here, except that here we have cosine times sinus, but that doesn't really matter the order, right? Because you had 3 multiplied 4 equals 4 multiplied by 3. Or whatever you multiply with each other, you can shift the order. Okay, let's take the e. Again, we need to find the first derivative. So what do we have here? We have something with x multiplied with something else with an x in it. So this is typical the product rule again. So in order to do that, I need to write a little side note here. The derivative of both of them, ex, is very easy to find the derivative of. This one is worse. And here you need to be careful, because this is the x that is squared, not the whole cosine thing. Remember, this one means this. But when you put the squared thing after the x, you take the cosine of x squared. So in this case, you will first need to use the chain rule, and the derivative of cosine is sine. And then we use the chain rule and find the derivative of what's inside the parentheses. Okay. So if we use the product rule here, we then take the derivative of the first one, which is ex over here, times the second one, plus the first one times the derivative of the second. Okay. This could be made a little bit prettier if we take the ex outside of a parenthesis. And we also like to take 2x in front of in front of the sign thing. But this would be a correct answer. You could also stop here if you want, but if you want to make it prettier, please do. Okay, now we have the f, and that might be the one that is most difficult here. So we have something by with x in it multiplied by something else with x in it. And since we have that, integration by part is an idea. You could also use substitution, which might be a bit simpler in this case. The reason you can use substitution is that you could use the derivative of, if you set u equal to sinus x and you find the derivative, that would be cosinus x. And that you already have in your integration thing. I always have to check with the signs here, because is the derivative of sine plus or minus cosine? In this case it is plus, but I always make a little stop just to check. Okay. Actually, I think that would be the simpler one to use substitution. But I will do both. Okay, so if you don't understand the integration by part thing, just stay tuned and we will do a substitution also. Okay, so let's say we use integration by parts. Then we take u equal to cosine and the v dx equal to sine. So we find the derivative of the u, which will then be minus sinus x. And the v would be minus cosine x. Again, make sure you're are really careful with the signs here. Okay. And then we have this integral. So remember the integration by part thing. Let's use the same notation over here. So this is the rule. I notice that if you write the v dx or the v with this apostrophe thing, that simply depends on the notation you use. It's the same meaning. Okay, so now we have u here, which is our cosine, and our v, derivative of v, which is our sine. So it is all lined up correctly. So we now take u times v. So we take the u times the v. And then we have a minus sign. This is our rule. And then we take the u derivative minus sinus times the v, which is minus cosinus. Okay, let's do it once more, make it a little bit prettier with all the signs. So we have a minus here and a minus here and a minus here, so we get a minus in front. And then we have a sinus and a cosinus. 3 minuses. So, the first glance, it seems like we didn't get anywhere, because this is exactly what we had started out with. It didn't make it any easier, except for one thing, that since these are equal, we could move this term to the other side, and we will then get 2 of these. Since we now have an integration stuff here, and not on the other side, we need to add a c. Because we will get an unknown c out of this, an unknown of that. And we still get something unknown out of this, so we need to have something unknown on the other side as well. And that will give us our answer already, because now we just need to divide by 2. If you call this C, or you drop it and you put a C marked, that's up to you. Okay, so that would be one way of solving it. So let's make an alternative. Substitution. In math, there are often different ways to solve each question, and which way you decide to solve it, that's totally up to you. So let's do this again. So as I said, if we choose u as our sign, we could divide that and get our derivative of u. Now I just need to make sure that our signs are okay. Isn't that minus cosine? I need to check the formula sheet. If we have sine and we find a derivative of that, that's minus cosine. No, plus cosine. Okay. So, this will give us du over cosine x equal to dx. So, pretty sure there's something with the signs here. Anyway, cosine x times our u, and our dx will be du over cosine x. So these will cancel, and we'll have u du, which is half a u squared plus a c. Now, 2 totally different answers. You see here, you have minus cosinus squared, and here we have sinus x squared. The thing is that sinus x squared plus a cosinus x squared equals 1. So this one would basically be 1 minus cosinus x squared plus a c. So we have minus cosinus x squared divided by 2 plus a half plus c. So if we compare these, you'll see that here you you will have one constant, and here you will have something else. So these two answers are the same because of this identity. I almost managed to confuse myself. Okay, the last one. Here we are given that this one, and again, this one equals this one here. So the notation is simply trying to confuse you. So this is what we're given. And I want to find this. So the first thing I do is that I put the constant in front, which I'm allowed to do according to the formula sheet. And this is what I'm given. See, this one is totally equal to this one. So this will then be 2 multiplied by all of this stuff here. Which would be, if you take 2 times the half, you get 1. So you get x minus sinus x cosinus x plus 2c. And you could exchange this for another c if you want. So this is a very, very simple subtask, but it looks difficult.